The Circular Buffer Manager module implements a fixed-size, wraparound memory structure for sequential data storage and retrieval. The buffer maintains two pointers, the write head and the read head. The write head advances monotonically as data is appended. The read head advances as data is consumed. When the write head reaches the buffer boundary, it wraps to the beginning, provided the read head has advanced sufficiently to prevent data overlap. Initialization of the Circular Buffer Manager requires specification of the buffer capacity in bytes. The capacity parameter accepts integer values between 256 and 4,294,967,296. Values smaller than 256 will be rejected with an error code above capacity minimum. The buffer is allocated as a contiguous memory region during the init function call. The write pointer and read pointer are both initialized to 0. The write operation appends data to the buffer at the current write head position. The function accepts a byte array and length parameter. If the combined length of available space and the data size exceeds capacity, the operation will block until the read head advances. The write head position is updated after data is copied. No data validation or transformation is performed. The buffer treats all input as opaque binary content. The read operation retrieves data from the buffer starting at the read head position. The caller specifies the number of bytes to read. If fewer bytes are available than requested, the read will return only the available bytes and set a partial flag in the return structure. The read pointer advances exactly by the number of bytes returned. Calling read on an empty buffer returns immediately with a byte count of 0. Wraparound behavior occurs when the write head position plus the data length exceeds the buffer boundary. The write operation automatically copies the first portion of data to the end of the buffer, then continues from the beginning. This wraparound is transparent to the caller. The read operation similarly handles wraparound by returning data in the order it was written, regardless of positional boundaries, within the underlying memory region. The available write space function returns the number of bytes currently available for writing without blocking. This value is calculated as the distance from the write head to the read head, minus 1 byte to prevent write pointer from catching the read pointer. If the read head is ahead of the write head, available space is simply the difference. If write head is ahead, available space wraps around the boundary. The available read data function returns the count of bytes available for reading. This is calculated as the number of bytes between the read head and write head. If the write head is ahead of the read head, the count is the direct difference. If the write head has wrapped, the count includes the bytes from the read head to the end of the buffer, plus bytes from the beginning to the current write head position. Blocking behavior is configured through the set blocking mode function. When blocking mode is enabled and the write operation cannot complete immediately due to insufficient space, the operation will suspend the calling thread until space becomes available. The read operation similarly blocks if the caller attempts to read from an empty buffer. Blocking operations may be interrupted by system signals, which return an error code above interrupted. Non-blocking mode is activated by passing a 0 timeout value to set blocking mode. In non-blocking mode, write operations return immediately with a partial write count if insufficient space exists. Read operations return 0 bytes if no data is available. This mode is suitable for polling-based applications or event-driven systems where threads cannot be suspended. The return value indicates whether the operation completed fully or was only partially executed. The peek operation provides read-only access to buffer contents without advancing the read pointer. This is useful for inspection or pattern matching before actual consumption. Peek accepts the same offset and length parameters as read. Wraparound is handled transparently. If the peek offset plus length exceeds available data, the peek returns only the available bytes. Multiple peek operations return identical results until the read pointer is explicitly advanced. The reset function clears the buffer and reinitializes both pointers to 0. This operation does not deallocate the underlying memory, it only resets the logical state. Any data currently in the buffer becomes inaccessible. Reset can be called safely at any time, even while other threads are waiting on blocking operations. Those threads will receive an error code above reset during wait, and must be prepared to handle this condition. Thread safety is guaranteed through internal mutex locking. All public operations acquire a lock before manipulating pointer or memory state. Read and write operations cannot proceed concurrently. The mutex ensures mutual exclusion. However, peek operations may occur concurrently with themselves, as they do not modify state. Deadlock scenarios are prevented by a strict lock ordering protocol where the buffer lock is always the outermost lock. Memory efficiency is optimized through use of a single contiguous allocation. The buffer requires no fragmentation. The memory footprint is exactly the capacity specified at initialization, plus a fixed overhead of 64 bytes for metadata and pointers. Cache locality is favorable because all operations access the same memory region. Alignment is automatically handled to match the system's natural word size, typically 64 bits on modern processors. Error handling follows a standard return code pattern. All functions return an error code or status value. The constant eboff success indicates successful completion. Error codes include eboff capacity minimum for invalid initialization parameters, eboff allocation failed for memory allocation failures, and eboff invalid handle for operations on uninitialized buffers. The error message function translates numeric codes to human-readable descriptions for login purposes. Statistics and monitoring functions provide runtime visibility. The getStatistics function returns a structure containing the current read and write pointer positions, total bytes written, total bytes read, and the number of times the write pointer wrapped around the boundary. These counters are useful for debugging and performance analysis. Statistics are maintained with minimal overhead and may be queried at any time without blocking. The destroy function deallocates all resources associated with the buffer instance. This includes the allocated memory region, internal synchronization primitives, and metadata structures. Any pending blocking operations are interrupted with an error code eboff buffer destroyed. After destruction, the buffer handle becomes invalid and must not be used. Resources are immediately returned to the system for reuse.